What is the atprotocol? I decided to make this video because Bluesky is really starting to gain some steam, and I imagine there's a lot of people out there like me who are from more of a technical background and are looking for a description of what the atprotocol actually is, and they're finding a lot of kind of vague answers, or at least that's been my experience. And so in this video I want to go over some of the stuff that I've discovered, and a lot of the stuff is sourced from they wrote a white paper back in, I think, February 2024. And I think this paper actually does a better job at explaining some of the stuff than the actual documentation that currently exists out there. And I think it would be helpful to look at the goals of the people that designed the atprotocol so that you can understand the context in which it was designed, basically the problem that it's solving, so you're not just looking at the solution in isolation. And in the paper they actually lay out their goals explicitly. And they say basically what they're trying to do is build a decentralized system in which there are different providers for the different parts of the system, and that users can basically swap them out as they wish. And I think this makes more sense if you understand the history of ActivityPub and basically Mastodon, the distributed social media application or platform, where originally I think the idea was that it would be distributed because users could have their own servers, but it ended up being kind of expensive in the end to run your own server and have basically the barrier, the technical capability barrier you needed to run your own server ended up being too high. And so that kind of undermined the usefulness of it because you ended up getting locked into a specific server, which then comes with other problems with following other users as well as having to buy in into the moderation that one server is providing. And so I think atprotocol is kind of like designed with all that experience in mind, where they want to be able to have the user kind of swap out these different components that build the whole application together, where the components can actually be run by different organizations, and then you can kind of combine them all together in the end to have a single application. And one of the services they point out in the paper is custom feeds. And this is basically just the algorithms that are used to curate the different posts that are displayed to you on Bluesky, which is the microblogging application. And they lay it out here. They say that our belief is that the problem lies not with algorithms per se, but rather with centrally controlled opaque algorithms that remove user agency and prioritize user engagement over all else. And I think this is something we all kind of witnessed on Twitter, where our algorithms sort of changed when Elon Musk took over. And I think a lot of people might remember that this centralized control thing is kind of a key aspect of what they're doing with atprotocol. They want the user to be able to switch from one social media site to another while maintaining their data and maintaining their identity. And basically this whole atprotocol thing is designed to facilitate that. And so it's just another example. Twitter, they pulled the free support for their access to their API. That's something that upset a lot of people. And they changed the way that the blue check marks worked. If you remember, they kind of signaled that someone was actually who they claimed to be, and that they had they were like a public figure almost. And a lot of people didn't like that, but it was kind of a core aspect of the way Twitter worked. And you see here, William Shatner's mad about it, although I just looked and he did end up buying a blue check mark, but he's also on Bluesky, so maybe there's hope for him yet. So let's go back and talk about some more of the technical stuff. So again, I'm trying to define the atprotocol, and when you go out and you look at the definitions, I think you might find what I found, which is that they're all these like super high-level abstract things. And so even in this paper, in the first paragraph, they introduced the atprotocol as a decentralized foundation for social networking. And I remember reading that and I was like, foundation? Like, what's that? Like, what's that mean? And I think they chose that word specifically because the atprotocol is kind of like bigger than just an atprotocol, and it doesn't really fit any specific term. Like, it's not like a framework, it's not an architecture, it's not really even a protocol, even though it's called atprotocol. It's more of like an umbrella for all these different things. And again, on the Wikipedia page, when they define it, they say it's a protocol and an open standard. And that's probably the best description I've seen so far. And so even on their website, when they list the different specs, they have the atprotocol as a spec listed separately from like these other things, which kind of are parts of the different architecture in the atprotocol, the different things you need for authentication and synchronization of data and things like that. And so if you're confused about why the atprotocol is kind of hard to define, it's because it's just kind of hard to define. It's kind of an umbrella term for lots of different things. And I think it kind of makes sense if you think about it kind of like the way that HTTP and the World Wide Web are connected, where it's like with HTTP, that's the protocol that's used, or at least originally it was used for communication between a web browser and a web server. And so like the HTTP protocol, even though you can kind of define it in isolation, it kind of doesn't really make sense without thinking about the World Wide Web architecture overall, more widely, where you have like DNS servers and you have even like the web browser, like how a web browser works, how HTML and JavaScript are, shipped on within web pages and things like that. But like that's kind of a separate thing than the actual HTTP protocol itself. But I did note, I went back and I looked at the spec, and I think they're so closely linked that it's actually the second sentence of the entire spec. It mentions the World Wide Web, and so I think it's okay to kind of think of the atprotocol as kind of like this whole architecture and all these different things together. Although one thing that I've noticed is people have started using this term, the atmosphere, which is kind of funny, where it's like HTTP is to the World Wide Web as the atprotocol is to the atmosphere, where you can think of the atmosphere as like the user's personal data servers as well as all these applications and basically the whole system working together. And and then the atprotocol itself, it's also a little bit tricky to define because part of it is kind of defining different schemas, and they call it a lexicon. I'll go over that a little bit more later. But so like on the atprotocol website, they have this little thing here. They say, while the web exchanges documents, the atprotocol exchanges schematic and semantic information, enabling the software from different organizations to understand each other's data. And so you can see that it's like this really high-level thing. It's almost like the atprotocol is itself a protocol for exchanging different protocols, basically, for defining how data and communication of that data works between different organizations. And that's why it's so hard to define. Okay, so that was very high level and abstract. So let's make this more concrete by looking at the actual components of the architecture as it's being used within Bluesky. And so this diagram comes from the paper, and I've seen it in some other places. And it looks more complicated than it actually is because they're repeating the components on the vertical axis to show that this thing's distributed. So basically any of these little boxes can be run by different organizations or owned by different people. And this whole thing's supposed to continue working as is, and users can swap out different components. And so the key components here are the personal data servers. That's basically where the users keep their data, which in Bluesky would be like the posts that the user made, who they're following, and what posts they like. There's also the relay, which basically it scrapes the data from all the different personal data servers that exist. And then that creates what they call the fire hose, which is just a stream of data, and that's consumed by both the feed generators, which basically pluck out the specific posts that users might want to see, as well as labelers, where they can look at any piece of content and apply a label to it. And then that's ultimately consumed by the app view, which is basically just the application, like the sort of their Bluesky microblogging application, which shows the different posts to the users. And then this kind of repeats. So again, this diagram looks more complicated than it actually is because the users own their own data. When the users if they want to make a post, they don't actually then send the data to the app view. They send the data to their own personal data server. And so then in theory, once the data is in the data server, then would get picked up again by the relay and then ultimately pulled into the app view via whatever feed generator or whatever that is. The previous diagram can be then simplified into this thing, which was made just to show the circular data flow, where you have here the app server, which would be the app view and the client. And then the key idea is that when a user wants to update their data, if they want to make a post or something, they don't send that directly to the application to update its own internal state. They actually push their data to their own personal data store, their PDS, and only after that's read in through the here this edge says event log, but that would be like the relay and custom feed or however that's implemented. Only then would that be reflected in the actual application. And so this is just kind of showing that really the source of truth of the data is the user's personal data store, not the application. And then within this documentation page, they were showing that basically for practical reasons, the app server is really going to have its own view of the data. So like it's not going to have your application isn't going to have connections to all those different user repos. You're going to really depend on the event log or however that architecture is set up, and you're going to have like a view of all the user's data. And so it's almost like a caching layer for all the distributed users' data. And again, for practical reasons, when the user wants to update some state or whatever, instead of waiting for that data to go all the way through the cycle, through the personal data store and then read back in, that you can short circuit it and do kind of like an optimistic update. And I thought this was kind of cute because this is a pattern that you do in all sorts of different places, you know, from the front end to anything, even like lower level computer architecture kind of things kind of have this idea where you have like a caching layer and then optimistic updates and all sorts of things like that. And so another way of looking at this I was thinking about is that from the point of view of people that are going to be designing these applications, living over here on the app server part, basically atproto doesn't make anything easier, you know. Like if you just remove these edges and then only think about the optimistic edge here, then this would just be like a normal application. And so to support atproto, it's actually going to be more work because you're going to be pushing the data out to the PDS. You're also going to have to deal with reading in data from the fire hose or wherever you want to have that implemented. And so in order to have these applications buy into the atproto, there's going to have to be some type of either just user demand where users are like, I really want my data in my own personal data store, or there's going to have to be some kind of synergistic effect where there's lots of different services that the users can combine within a single application and get some type of benefit from, where basically everyone buys into this and then benefits. And I don't think that's that far-fetched. I was thinking recently about, like, if you think about like the way the Twitter feed worked, if you imagine like Twitter having like YouTube embeds, where like you have a feed, your YouTube or your Twitter feed would then have a bunch of Twitter or YouTube videos embedded. Like that's kind of like already that effect where you have these different organizations, you have Twitter and YouTube, and they're kind of working together within a single application. And that does seem like something that could work. Already there's at least one organization, I'm not sure if it's like a company or what it is, it's called Smokestack, which is using the atproto to do like event planning, like RSVP type things. So I think it already works within Bluesky. So you can basically invite people to some type of event and have them RSVP, and all this stuff already exists within the separate organization. And then if you're ever unhappy with that organization, another one can pop up or they can fork. And I do think that there's definitely a lot of potential there, but it really all kind of relies on, or it kind of hinges on having lots of different services actually exist, because otherwise, people are just going to opt into this smaller loop here, and there's not going to be much benefit from having users own their own data. Other than, I guess, certain users are always going to buy into that. Like if you look at Mastodon, it's a distributed thing, and people have been using it, but like it never really reached some crazy wide adoption. And so I do think that Bluesky, especially with the recent Twitter and X things, definitely does have some hope of having this actually take off and become a real thing. And to get back into some of the technical discussions, I just wanted to point out some things. So within the personal data store, the PDS, the data is stored within a Merkle search tree, which I kind of think about it, it's almost like a signed Git repo where each update to the thing has to be signed by the user's public or private key so that you know that it's actually the user that changed it. And then the app protocol itself has all sorts of descriptions of how that's done, as well as the interaction between the PDS and anything that wants to listen in on it. And so there's all sorts of stuff within the specs for like the synchronization of the PDS. And so it's kind of set up so that you can get a kind of like a live feed where you only get the most recent changes. And then there's also different specs or different modes for interacting with it to get what they keep calling a backfilling of prior content. So basically you don't just want only the latest data, you're going to want to have all their posts. And so they have different ways of interacting with it to do that type of thing. And they also have specs for the event streams for interacting with things. And there's also these different data formats for interacting with stuff. And they use OAuth, but I think they have like a specific or their own kind of way of dealing with things. And so there's the app protocol is basically describing the interactions between all these different components. And the next important component, because this is a distributed system, and then they wanted to have it so that users could maintain their identity and maintain all their data while switching through different services, is you need to have an ID that uniquely identifies you. And so within atproto, they're using, it's a different standard. It wasn't defined by them. It's a W3C standard for decentralized IDs, which is what DID stands for. And the basic idea is that a DID gets resolved to a JSON document. And so there's actually a server that will respond with the document when you make the requests, kind of like the domain name server. You have a domain name and you make a request and you get back an IP address. Here you have, you make the request with the DID and it returns the document. And within the document it has this extra data that you need. And so it'll say what your handle is. And within Bluesky, they're doing this unique thing where your handles are all just actually domain names. And so that's kind of piggybacking on the credibility of the DNS servers. Like the idea is that if your handle is newyorktimes.com, then you don't need a blue check to show that you're newyorktimes.com. And also because you can just use subdomains, like each user isn't going to have to buy their own subdomain buy their own domain if they don't want to, but they are able to. And because it's part of the document, they can always just update their document. There's basically a scheme where you sign the previous one with your public key to make an update to it. And so also within the document is your public key, obviously, which has to be used to show that you signed your data in your different in your personal data store. And then there's also, it says the location of your PDS. And so all this stuff is contained within the DID document. And then this diagram showing that there's like this two-way connection, because the DID document points to your domain name. And then the way you set this up is from your domain name, you can either add an entry to the DNS. It's like a DNS text entry that then says what your DID is, or you can also have it so that at a specific endpoint on a website you can serve like I think it's probably like a JSON response that says what the DID is. And so this way you have your unique identity, but you can change your handle, and you can also maintain your own personal data store and move your data from one place to another without having to create a new account, which is basically one of the driving factors behind working on atproto, specifically, to overcome this kind of shortcoming of ActivityPub and Mastodon. And the final technical piece for understanding atproto is understanding what they call lexicons. And the key idea is that within any user's PDS, because it's their own data, they own it, you can store any data you want. And so the idea is that if you're an application developer and you want to make some type of application where the user is going to store their data within their own PDS, is you publish a lexicon, which is just the schema for the data that's going to be saved in the PDS, as well as some RPC endpoints for modifying that data. And then the central idea is, because this whole thing's meant to be shared, where different organizations, different applications can then use that data, is because you're publishing your schema and how to interact with it, then different application developers can then use that data, because at the end of the day it's the user's data that's owned. Whoever's developing that application doesn't actually own it. And so this is actually already in use. I think I already mentioned Smoke Signal, the RSVP app, and so they publish their lexicon for their event planning stuff. And then there's another organization called Whitewind that it's kind of like Bluesky's the microblogging side of it, and then Whitewind is like a long form blogging platform, and then they publish their lexicon for how their data is stored for their longer form blogs. And so this lexicon thing, it kind of seems a little intimidating at first, but it's actually quite simple. You just it's like defining any other schema, and then stuff's all pretty well explained in the documentation. And from the point of view of developing applications, it's actually quite easy to use. So like you just define your lexicon in some file, and then they have different dev tools already set up for the different languages where you just run some script, and then given that lexicon, so this is the TypeScript one, and this is I guess the quick start on the App Protocol website. It will generate types for you for your TypeScript, as well as validators. So then you can use that when you're listening in on the Firehose to make sure that the data is in the right format and of the type that you're interested in. And all this stuff is kind of useful from the point of view of developing applications. And it's all quite easy to use. One of the nice things I've noticed about both Bluesky and atproto is, I think because it's like small teams and this is relatively newer, I think the people that have been developing this stuff have kind of learned a lot of lessons over the years from their time with like nasty different APIs and GraphQL and all this kind of extra complexity stuff that I think didn't really pay off in terms of how it helped with software engineering. And so like all their examples are so easy to use. This API is like incredible. And so all this stuff's kind of set up to have people start, defining your own lexicons and making your own applications so all this stuff can work together. And I think this stuff can be really cool. One thing you might want to check out if you haven't seen it yet is there's these two different GitHub sites that just list all the different things that are going on and different resources to look into. It's called Awesome Bluesky, and then there's also Awesome atproto. And so if you want to get into that, please look into that. And I might make more technical videos as I go on and I learn more. And if you want me to do that, just like and subscribe, because otherwise I'm probably not going to. Because I have noticed that a lot of these atproto videos on YouTube that I'm looking at have not that many people looking at them. I think that's probably more of a discoverability issue on the YouTube side more than people not interested in it. But hopefully this video gets some views, and if you have any comments, let me know. And thanks for watching.